This is the prep packet video for Unit 4, Chapter 9.3. We're looking at Objective 3, where we use the quotient rule for square roots. The quotient rule is very handy, and we've taken a look at it a little bit before. And it gives you the idea that if you start out with, here this is the same example as above, if you start out with the square root of 36 over the square root of 9, you can go two ways with it. You can either take the square root of the numerator, which is 6, and the square root of the denominator, which is 3, and then from there reduce the fraction and end up with 2. You could also do it another way where you take the square root of the whole fraction, 36 over 9, reduce the fraction first if you can, and then end up with 2. Either way, because this is the one case where division that order doesn't matter. So we're using the quotient rule for square roots. And let's take a look at some examples. Here we have the square root of 8 over 49, which you can also write as, actually, first of all, let's see if we can do anything vertically. And 8 and 49 have nothing in common, so I'm going to move on and do this. The square root of 8 over the square root of 49. Now, 8 itself is not a perfect square, but let's see if it's hiding any inside it. 2, and then the square root of 49, I know, is 7. Here, I have a square root, a perfect square hiding in there. So the square root of 4 is 2, and it leaves behind a 2 over 7. Here we're going to look at this one, and let's take a look again. I want to look vertically first, and on this one I actually can do the work before I take the square root. So 5 goes into 25 5 times. So I go from here to the square root of 5. Now 5 is a prime number, so it's just going to have to stay right the way it is. You may be tempted to use a calculator, but for now I would just like you to leave them like that. Let's give this another look-see. Here we have the square root of 27 over the square root of g to the 6th. I can break this up because there's nothing I can do vertically, so I'm going to have the square root of 27 over the square root of g to the 6th. Now, we haven't looked at this much yet, but let's take a look at the top one, sorry. That's the same as 9 times 3, right? And that'll go to, we'll take the square root out. So that's going to take out the 3 and leave behind a 3 square root. Here with g to the 6th, that's the same as g to the 3rd squared, right? And remember, if this is the same as this, they cancel each other out, and I'm left with just the radicand. So I have root 3 times the square root of 3 over g to the 3rd. You might be tempted to do something here, but don't. This is done. You don't have to do any more. Let's take a look at this one. I see lots of zeros floating around, so I'm going to do things vertically first. So I can take it out of 2 radicals and turn it into one giant radical. And here I can deal with that. So 10 goes into 120 12 times. So that's the same as the square root of 12. And that's the same as the square root of 4 times 3, which is the same as 2, because I can take the square root of the 4, root 3. And what I want you to do from here is go to the U tries on page 538 for more practice. Make sure you include your work with the prep packet. And that's it for this objective. We'll see you on the next video.